Properties of ionic compound are related to their structure. So if I give you sodium chloride as example, its electrostatic attraction between sodium, a positive ion, and chloride, a negative ion. But it doesn't stop here as a unit cell. It actually goes on, and the structure is known as lattice. So there are positive and negative attachments of positive ion and negative ion. And properties such as melting point, solubility, and volatility has to do with this structure. So this is a two-dimensional dimension of a sodium chloride. This lattice structure goes on forever. They definitely are solid and have high melting point because of the strong electrostatic attraction. For sodium chloride, melting point is about 801. For magnesium oxide is about 2800. And if you're being challenged why this one is so much higher than sodium chloride, simply if you look at magnesium, it's 2 plus and oxygen is 2 minus, versus sodium, which is 1 plus, and chlorine, which is 1 minus. Magnesium not only has twice the charge, but it's also smaller in size, and oxygen as well. Compared to chlorine, oxygen is twice the charge and smaller in size. Therefore, this makes it a stronger lattice structure due to stronger electrostatic force. So they have high melting point because of the strong electrostatic attraction. They are not volatile, or if they have any volatility, it's very small. And volatile is tendency to turn into gas and vaporize. They conduct electricity in molten when they produce free moving particles, which are ions. So once you separate sodium from chlorine, then they can conduct electricity. So in molten, they can do so, and you have to melt them in order to achieve that. But in the process, they get decomposed. The ions are being destroyed. Solubility is also taking place in water, which is a polar solvent, because ionic compounds are extreme of polarity, so they dissolve in polar solvents such as water, but they do not dissolve in non-polar solvent. So these are few properties that you need to know for IB, such as melting point, high, volatility, non-conductivity in molten or aqueous, solubility, yes, in water, because water is polar.